Sample questions under wired network solutions. Refer to this exhibit. All four switches in the diagram have been configured with the region name Aruba 1. What two other MSTP configurations must match for switches within the same MST region? Look at the next question under wired network solutions. Refer to this exhibit. It shows some information about the command output of show VLAN. The above command was applied to an Aruba ACSA7300M 24-port switch with 4-port SFP56 uplinks. All ports are set as access switch ports. Which ports carry VLAN 1 traffic? Next question under wired network solutions. Okay, refer to this exhibit. What configuration is needed in order for show LLDP configuration to show this output? So they are asking what are the two OSPF attributes within the hello messages that must match to successfully establish neighbor relationships. Okay. Match each description to the correct term. So you can see some terms: ASIC, control plane, data plane, management plane. Hello everyone. Welcome to today's online class from 591lab.com. Today we will be discussing sample questions of Aruba Certified Switching Associate exam. In this session today, you will understand few concepts related to Aruba wired solutions. Before I move on, let me introduce 591lab.com. 591lab.com is the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Today we will be covering few topics such as configuring wired network solutions, network architectures and technologies, function and features of Aruba products and solutions, optimize Aruba wired solutions, troubleshooting, management, monitoring, and operate Aruba solutions from Aruba Certified Switching Associate exam objectives. Okay, let's look at the sample questions under wired network solutions. Refer to this exhibit. All four switches in the diagram have been configured with the region name Aruba 1. What two other MSTP configurations must match for switches within the same MST region? Okay, we have to select two answers. So there are four switches. The upper two switches, they are called root switch core 1 and backup core 2. And there are access layer switches, non-root access 1 and access 2. So basically here these access layer switches are non-root switches, and this core 1 is acting as a root switch for certain set of VLANs, and for the core 2 is acting as a primary switch for another set of VLANs. So it's a kind of creating a couple of instances and mapping those VLANs sets to those instances. So I have simulated this similar scenario in GNS3. Let me show you that. Here is the simulation of this AOSCX switches in GNS3. I have used AOSCX simulator. So here I have this core 1 and core 2, and I have created VLAN 1 to 10 in all of these switches, and I have created two instances, MSTP instances, multiple spanning tree instances, instance 1 and instance 2 in all of these switches. And for the instance 1, I have mapped VLAN 1 to 5, and instance 2, I have mapped VLAN 6 to 10 in all of these switches. In core 1, because core 1 should be acting as the root switch for the instance 1, so I have made its priority as 1, that is lower than the instance 2's priority. For the same switch, for the instance 2, I have made the priority as 2. On the other switch, core 2, for the instance 1, I have made the priority 2, and for the instance 2, I have made the priority 1. So the lower priority is for instance 2 here in the backup switch, but here the lower priority is for instance 1. So the idea here is when the priority is lower, that the switch becomes root for that instance. So in this case, core 1 should be the root for instance 1. That is for this VLAN 1 to 5. This will be the root. In here, the lower priority is for instance 2. So for the VLAN 6 to 10, this core 2 will be the root. And this VLAN mapping is same in all these switches. Let me show you the configuration. And all these inter-switch links are trunk. They have configured as trunk. So let me show you the first is root switch. This core 1. So this is the core 1. This switch. Configuration of this core 1 switch. Let me show you the show run. So here you can see I have created VLAN 1 to 10. I have enabled the spanning tree. In global level, I have made the spanning tree priority as 1 because this is the core switch, the root switch for the entire topology. And I have configured the config name, that is this region name, as the Aruba 1. And config revision number is configured as 1. And I have created these two instances, instance 1 and instance 2. For the instance 1, I have mapped VLAN 1 to 5. 1, 2, 3, 4, 5 I have mapped to instance 1. And for the instance 1, I gave priority 1 to make this core 1 as the root switch for this set of VLANs 1 to 5. For the instance 2, I have mapped VLANs 6, 7, 8, 9, 10, 6 to 10 are mapped to instance 2. For the instance 2, I gave priority number 2. Okay, that is higher priority. But if the priority number is lower, so then that switch becomes a root for that instance. So the other configuration is normal, the interface level configuration. So they are trunk links, allowed all these VLANs. And let me show you the other switch also, the core 2. So let us compare the configurations of core 1 and core 2. This is the core 2. Let me show you the show run. See, now just compare this MSTP configurations here. Spanning tree is enabled. Okay, VLANs are same. 1 to 10 is configured. Config name is same, Aruba 1 in all the switches. Config revision number is also same, config revision 1. And the instance mapping is also same, instance 1, 1 to 5, instance 2, 6 to 10. But the priority, instance 1, here is priority 1, but here is priority 2. So the lower priority becomes the root. That's why core 1 is acting as root switch for VLAN 1 to 5. And instance 2, priority is 1 here. So the core 2 is acting as the root for instance 2. So this is how you compare this MSTP configurations in these two switches. Let me show you the access layer switches as well. Access 1. This is access 1. Here also I have configured this region name as Aruba 1 and config revision also same 1. And VLAN instance mapping, instance 1 to 5 and instance 2 to 6 to 10. So instance VLAN, instance mapping also same, instance to VLAN mapping also same, configuration revision also same, and region name also same in all these 4 switches. Let me show you the access 2. So here also config name, revision, instance mapping to VLAN are also same. So let me show you the current spanning tree MST details. show span entry MST. So you can see the instances. MST0 is the default instance. Whatever the rest of the VLANs from 11 to 4094 are mapped to this MST0 instance. So we are not focusing on the MST0 because we have no VLANs in that. So our VLANs are on MST 1 and 2. Let me show you MST1, instance 1. So the VLANs mapped 1 to 5 is mapped to instance 1. And you can see the root port. Here the root port is 1/1/2. I'm talking about the access 2 switch, this switch. So 1/1/2 is connecting to the core 1. So core 1 is the root for instance 1. So it proves that it's correct and it's working properly as we expected, and it's forwarding. For the instance 2, MST2, the root is 1/1/1. That is core 2. So that is the root because instance 2 priority is lower. That is for the VLAN 6 to 10. For the 6 to 10, root is the core 2. That's why the 1/1/1 is the root port for this access 2. So this access 2 is working properly. Let me show you access 1 also. Show span entry MST. Let's check the instances. So 1 to 5 is mapped to instance 1. Who is the root? 1/1/1 is the root port. So for the access 1, 1/1/1 is connecting to core 1. So core 1 is the root for instance 1. That is correct. And the other instance 2, VLAN 6 to 10. The root port is 1/1/2. 1/1/2. 1/1/2 is this one. It is connecting to core 2. So core 2 is the root for MST instance 2. That is for the VLAN 6 to 10 because of lower priority. So we access 1 also working properly. So that is correct. The idea you have to get from this is the configuration what we have done. Region name is common for all 4 switches, and what I have done, config revision number also same, and instance to VLAN mapping also same, only the priority is changing in core 1 and core 2. Okay, hope you got the idea. So let me check the answers. So answers are MST version number. Actually, I have not configured any version number. MST revision number. Yes, I have configuration revision as 1. So B is correct because I have configured same revision number in all these switches. MST VLAN to instance mapping. Yes, that is also correct because I have configured same VLAN to instance mapping. MST region type. I never came across this region type. Only the region name is Aruba 1. There's no region type, so D is not correct. MST bridge ID. I didn't configure any same bridge ID in any of these switches. So I have configured revision number and VLAN to instance mapping. Same on these switches. So B and C are correct. Take a look at the next question under wired network solutions. Refer to this exhibit. It shows some information about the command output of show VLAN. The above command was applied to an Aruba AOSCX6300M 24-port switch with 4-port SFP56 uplinks. All ports are set as access switch ports. Which ports carry VLAN 1 traffic? Okay, let's look at this simulation. I have one 6300 switch. So all these ports by default are in routed mode, and I have connected some PCs to these 3 ports. And let me show you the configuration here. I have configured these VLANs, show VLAN. So I have configured 10 and 20, 10 for engineering and 20 for guest. Okay. And in my running configuration, what I have done, let me show you. This is my port configuration. There are 7 ports in this simulation. So 1 to 7, 1/1/1 up to 1/1/7. So the first port 1, 1, 2, 3, they are access to VLAN 10. So I have disabled routing. So I have made them as switch ports, all these as switch ports. Then I first port to third port 1 to 3, I have made access to VLAN 10. 5 and 6 access to VLAN 20, VLAN access 20 and VLAN access 10. So those are the commands I used. Now the remaining ports, that is port number 4 and port number 7. So they are just remaining in the default VLAN, that is VLAN 1. So let's look at the show VLAN output here. Let me show you it here. Okay. So this is the clear picture of what's happening. So now port number 1 to 3, they are part of VLAN 10. Port number 5 to 6 are part of VLAN 20. And remaining ports, that is 4 and 7, because in my simulation I don't have all the ports like in actual real switch. But the concept you have to understand here, whatever the ports not assigned to these VLANs are just remaining with this VLAN 1. So it will show here as default and VLAN 1, and these are the port numbers 4 and 7. So all other ports are assigned to the other VLANs. So that is the concept you have to understand. So then we'll go back to the question and check the answers. Here now, this is a 24 port switch with 4 SFP56 uplinks. Then totally there are 28 ports. So they have given outputs 1 to 7 they have assigned to VLAN 10, then 11 to 14 to 20. So then 1 to 7. So then 8, 9, 10. So 8, 9, 10 is not assigned to these VLAN 10 and 20. So 8, 9, 10 should be on VLAN 1. Okay. Then again 11 to 14 assigned to 20. So from 14 afterwards, that is 15 up to 28 are assigned to VLAN 1 because they just remain in the VLAN 1. So let's check the answers. Option A, 1/1/1 to 24. No, it's wrong because already 1 to 7 is assigned to VLAN 10. A is wrong. Port number 1 to 28. No, they are not. That is also wrong because 1 to 7 is on 10 and 11 to 14 on 20. So B or A and B are wrong. Let's check C. 1, 1, 8, 10. How about 9? Now this is also wrong. 8 and 10, yes, they are part of VLAN 1. But 15 to 24, they are also part of VLAN 1, but certain ports are missing here. Let's check D. 8 to 10. 8 to 10, yes, 8 to 10 should be on 1 because up to 7 assigned to the VLAN 10. Then 8, 9, 10 are on VLAN 1. So 8, 9, 10 on VLAN 1. Then after 14, that is 15, 16, up to 28. Yes, 15 to 28, they are on VLAN 1. So the correct answer is option D. Let's move on to the next question under wired network solutions. Okay, refer to this exhibit. What configuration is needed in order for show LLDP configuration to show this output? Okay, this output, the command output is show LLDP configuration. So there are LLDP global configuration parameters are there. whether it is enabled, the transmit interval and various parameters, and TLV is advertised, then LLDP port configuration. So all these information are shown under show LLDP configuration. So let's go back to the previous simulation and check whether these are possible. I mean, these are whether we can see these outputs. Here, let me open this. Okay, because you can see here, I have not configured any LLDP related commands here. You can see my show run. So no LLDP configured. I didn't configure manually anything. So let me issue that command. So LLDP configuration. Yes, you can see some output. Let me check. Okay. Let me check. Show LLDP configuration. Yes, LLDP enabled. Yes. Transmit interval, some parameters, TLV is advertised, it's visible. Then LLDP port configuration, so they are enabled. Yes, I mean this is visible and it's already enabled. I didn't do anything. So that means by default this LLDP is enabled globally and on port wise. I didn't configure anything related to LLDP to get this output. Okay, let's go back to the answers. Okay, let's check the answers. Enabling LLDP on the interfaces only. I didn't do any interface configuration for LLDP. So A is wrong. Configuring LLDP both globally and on the interfaces. I didn't do any configuration. B also wrong. None. LLDP is enabled by default on Aruba switches. Yes, that should be the correct answer. Configuring LLDP globally only. I didn't configure anything. So C is the correct answer because I didn't do any configuration related to LLDP, but that switch was showing this output when I issue this show LLDP configuration. So that means LLDP is enabled by default on Aruba switches. Correct answer is C. Let's move on to the other question. Under network architectures and technologies, what are two OSPF attributes within the hello messages that must match to successfully establish neighbor relationships? We have to select two answers. So let's simulate this OSPF functionality using the ARCX simulator. Okay, here's the simulation. So I have two layer 3 switches here. So I have connected them using single interface 1/1/1, and they are part of the same area. These two interfaces are part of this OSPF area 0. So let's configure these two switches for OSPF and let's see how the neighborship is established. So let's go to this switch 1 and see this existing configuration. So existing, there's nothing, only the host name is configured. So let me configure OSPF. Go to configuration mode and let me go to this interface 1/1/1. I will configure this IP address. These are already, they are routed ports by default in the simulator. I'm configuring the IP 10.1/24 and let me make it no shut and let me configure OSPF also. Route OSPF, then the process ID. Okay, let me use process ID as 1. Then I will enable the OSPF. Then area, I'll use area 0. Okay, then router ID, I'll use some router ID like let's say 1111. Okay, then I'll put this interface 1/1/1 into this IP OSPF process 1 and area 0. So I have enabled OSPF here, and I put this 1/1/1/1 into OSPF process 1 area 0. Okay, let's configure the other switch as well. Switch 2. I'll first assign the IP on interface 1/1/1. This is 10.2/24. I'll put no shut. Then I'll enable OSPF. Let me use different process ID. Earlier I was using 1. For this particular switch, I'll use 2, because this OSPF process ID is local to the switch. I'll enable the OSPF, and area should be same, otherwise they will not make any neighborship. Area should be common because that is area 0, and route ID should be different. I'll use, let's say, 2222. Yes, that's it. Then I'll assign that interface to IP OSPF process is 2, area is 0. Okay, let me check show IP OSPF neighbor. Yes, neighbors are established, neighborship established, so full adjacency. And neighbor ID is 111, that is switch 1 is the 111, and neighbor address is 10.1 is other switch 1. So neighborship is established. So let me check the parameters of this switch and the other one related to OSPF. Let us compare the parameters. Let's look at this show IP OSPF, then we'll see interface. So IP interface, OSPF interface. So here you can see some parameters. Switch 1 is the backup designated router, it's up, and hello interval is 10, dead interval is 40. So all these parameters are there. So here also we'll see show IP OSPF interface. Here also you can see. So hello interval is here 10, here also 10, dead interval also 40 and 40, same. So these parameters look same. Now we have configured different process IDs, different route IDs, but area should be same. That is obvious. Area should be same, otherwise they will not become neighbors. So let's enable here the logging console. I just want to see whether when I changed, let me change the hello interval in one of these interface in this switch 1. So I'll change IP OSPF hello interval. So by default it is 10, so I'll make it 20 for this side. So let's see whether the neighborship is still same or it will become down. So let's wait for some time. Show IP OSPF neighbors. So still it is up. We'll wait. I think we have to wait for 40 seconds because that interval is ISC. So you can see what's happening. So let me see. Yes, no OSPF neighbor found on. Then I think I had to enable terminal monitor also. So let me change it back to 10. Now let's see whether neighborship is coming up or not. We'll wait for some time. Yes, something is going on. So now we'll see the neighbors. Yes, neighborship is up now. So then hello interval should be same on both switches. So if I make it 20 here, so let's say I will make it 20 here. So again this should go down. So I'll make the 20 on the other switch also. We'll try that way also. So I'll wait till the neighborship is there, because still the dead interval is not passed. So we have to wait for 40 seconds, around 40 seconds. Still, yes, something is going on. So it is down now. Let me see. Yes, now no OSPF neighbors. Now what I'm going to do now, I have set hello interval here as 20, and now on this switch also I'm going to change it to 20, and let's see whether it is coming up. Interface 1/1/1 IP OSPF hello interval 20. So let me show IP OSPF neighbors. Yes, now it is up. Can check again. Yes, it's up. Can check here also. Show IP OSPF neighbors. Yes, it is up. So the hello interval should be same, and even the dead interval. If the hello interval is same, because dead interval is derived by the hello interval. So in both switches, hello intervals are same. Okay, now you got the idea. So we'll go back to the question and check the answers. Okay, you can see the answers, router ID. So they are asking, what are the two OSPF attributes within the hello messages that must match to successfully establish neighbor relationships? Okay, so we have configured OSPF, and you have seen what we have configured. So router ID can be different, because I have configured on one switch 1111 and other switch 2222. So router ID are different. Hello and dead intervals, yes, that should be matching. So B is correct. Process ID, I configured 1 in another switch and 2 in the other. So those are different. Process IDs can be different. So C is not correct. Area ID, of course, it should be same area. So I have configured area same in both switches. Area should be same. Priority, I didn't configure any priority. I allow it, default priority. So I didn't configure any priority values. So priority is not a concern. So hello and dead intervals should be same in both switches, and area ID should be same. So B and D are correct answers. Let's move on to the other question. Match each description to the correct term. So you can see some terms: ASIC, control plane, data plane, management plane. And you can see some descriptions. So receives and sends frames by using application specific integrated circuits, and there are various descriptions. Okay, let's look at these terms. Let's identify what these terms means, and let's find some details on these terms. First, ASIC. Look at this Wikipedia. So what does it tell about the ASIC? ASIC is actually application specific integrated circuits. So these are purpose-built ICs for specific functions. Now in switches, they are used to do the faster switching, fast forwarding than in the software. Actually, it's a hardware-based forwarding. Okay, this is some support article for these main functions of these three switch planes. What are these three switch planes? Management, control, and data plane. So you can see management plane. This is HP from support center from hp.com. So management plane is you interact with this plane when you access the switch to manage or configure it. or to monitor. So the management plane is related to the configuration, management and monitoring. The control plane, that is the decision making plane that runs routing protocols and builds routing table, generates traffic source from the switch such as routing protocol updates, bridge protocol data units, handles the file system including configuration files. So all of these functions and the decision making things are done by the control plane. Data plane is another name for that is forwarding plane. So it does the forwarding. The forwarding plane, sometimes called as data plane, contains the data channels that receive and transmit traffic. This plane also includes control elements such as packet processors and schedulers. So basic idea of data plane is that is for the data forwarding. Control plane is the decision making. Management plane is just to manage, configure and monitor the switch. We have some idea on these terms. Let's go back to the question and check the answers. So now we'll read out these descriptions. Receives and sends frames by using application-specific integrated circuits. Okay, this is receives and send frames. That means it's a forwarding function. So who is doing the forwarding function? That is data plane. This is data plane. Let me write this. Okay, this is data plane, receives and send frames by using ASICs. Switches packets faster than using software. Obviously, this is ASIC. Because I told you ASICs are hardware-based forwarding. So ASICs switches the packets faster than using software. Determines packet forwarding using routing, switching, security and flow optimization. So this is the determination function, that is decision making function. Who is doing the decision making? That is control plane. This control plane. This is control plane. Handles switch monitoring. This is management. This is management. So I just put MGMT. We have solved the problem. So you can see the correct term matched to the descriptions. Okay, let's move on to the other question. Functions and features of Aruba products and solutions. So what is true about VSX? So this question is about VSX. So let's look at the VSX overview from the Aruba website. Okay, this is Aruba documentation. This is technology brief from Aruba website regarding VSX. This is for high availability design. This is a stacking method using two switches. You can use only two switches because this is applicable for core layer or top of rack switches in the data center. This is not suitable for the access layer, because access layer there will be a situation you need more than two switches to be stacked. So VSX is not suitable for that. VSF can be used for that. In the VSX they are not merged. Actually the control plane is only synchronized. See in this diagram, you can see in this diagram this is VSX, this is VSF, virtual stacking, and this Aruba VSX. In this virtual stacking, you can see the control plane is merged. Both switches become single control plane. So, but here in this VSX technology, stacking technology, each switch has their own independent control plane, but they are synced. Okay, let's go back to the answers. Option A, VSX is available on all Aruba OSCX switches except the 6300F model. No, VSX is not available in all the switches. VSX is available on 640, 6400 series and above. That is 8300, 6400, 10,000, 8400. So those are the models where VSX is available. So VSX is not available on 6300, 6200. So VSF is available on 6200 and 6300. So this is wrong. Option A is wrong. VSX is ideal for campus access layer deployment where ease of deployment is needed. No, VSX is not for the campus access layer. It is for the campus core and the data center top of rack. So B is wrong. VSX allows upgrading members with near zero downtime or loss of packets. Yes, that is correct because they have separate control planes. They are maintaining separate control planes. They can support near zero downtime and loss of packets. So C is correct. And option D, VSX is implemented on static port switches. VSX Plus is needed to stack chassis together. But it is wrong because there's no term called VSX Plus, and VSX is implemented on static port switches. That is also not correct because 6400 is a chassis based modular core switch and VSX is supported. So D is wrong. VSX runs separate control planes to reduce latency and improve performance. Yes, that is correct. They have separate control planes. So E is correct. So the correct answers are C and E. Let's move on to the next question. Match each description to the correct management tool for Aruba AOS-CX. So you can see two management tools, NetEdit and Aruba CX mobile app, and you have different descriptions. So you have to match which tool is used with these descriptions. Let's identify some information on these tools. Okay, let's look at the Aruba NetEdit. Now it is called multi-edit. Actually, it's a name change. This is the data sheet of this NetEdit. So it uses OVA file. So it is installed in VMware ESXi. So it's basically tool to validate the configuration and see the topology of the network. You can validate the configuration before doing the change management. And this can be used to discover discover third-party devices as well through SNMP. And AOS-CX are, I think, discovered using REST APIs. How it is discovering the devices. It uses LDP and REST APIs for CX switches and SNMP for third-party devices. So this is how it shows the topology in this NetEdit. Do multi-edit. You can select a couple of multiple devices at once, and you can push the configuration. You can edit the configuration at the same time in multiple devices. And using AOS-CX mobile app, you can onboard switches to this NetEdit tool. Okay, let's look at the AOS-CX mobile app also. So this is used to onboard the switches initially. Instead of wiring the console cables to the switches, you can connect via Bluetooth because these AOS-CX switches come with the Bluetooth dongle. So when you enable the Bluetooth connectivity in your mobile phone and install this CX mobile app, you connect the switches. It will discover the switch via Bluetooth and you just connect to the switch, and you can do certain initial configurations, and you can onboard this switch to the NetEdit tool to further configure, and you can do so many functions. You can transfer files between this switch and your mobile phone. You can share configuration files from your mobile device. You can copy running configuration to the startup, so you can access the switch CLI. So these functions you can do using this CX mobile app. Okay, let's go back to the answers and see. So the first description, we'll try to match these tools to these descriptions. Can run as an OVA. It is obvious this is NetEdit because NetEdit is installed as an OVA file in a VMware ESXi platform. This is NetEdit. Now this second description requires AOS-CX switches to support HTTPS, SSH and REST access. This is required for NetEdit because NetEdit need switches to support these protocols. This is also NetEdit because NetEdit use these, for example, REST access to discover these devices. Now third description, connects to switches via Bluetooth or Wi-Fi. So this is CX mobile app. So I'll just make it short, CX. This is CX mobile app because it uses Bluetooth or Wi-Fi to connect to the switch. Then next description includes a feature for stacking automation. Stacking automation can be done using CX mobile app. It will detect automatically the switches that is possible to stack. Then you can do the stacking using the mobile app. Then last description, supports SNMP version 2C to discover third-party devices. Third-party devices are discovered by NetEdit using SNMP version 2. That is correct. So this is NetEdit. Okay, now we have matched the tools to these descriptions. So let's move on to the next question. What is deep packet inspection? So let's look at this diagram. So this shows the fundamentals of this deep packet inspection. Now in conventional packet inspection, it will inspect only the layer 3 and layer 4. So it will not check the application layer in conventional packet inspection. Now with the deep packet inspection, you can see in this screen, it will check the up to the application layer also. So that is the main difference in DPI. So let's go back to the question and answers. Option A, a function of policy-based routing that examines the entire IPv4 header to forward traffic based on factors other than destination address. There's nothing related to policy-based routing for the deep packet inspection. So option A is wrong. Option B, a concept that applies to firewalls when examining packets only up through layer 4. Actually, the mistake here is only up through layer 4. It's not only up to layer 4, it's up to layer 7. It's up to application layer. So option B is wrong. Option C, a machine learning method of packet inspection for the purpose of choosing which dynamic routing protocol to automatically assign. No, it's not correct. It's not a machine learning method of packet inspection, and there is no relationship with this routing protocol assignment. So C is wrong. Option D, a firewall process of examining the packet header all the way to layer 7 in order to determine if the packet should be permitted or denied. Yes, that is correct, because it will inspect up to layer 7. So it will check all the way to layer 7. So option D is correct. Let's move on to the next question. Which command will suppress LLDP messages from egressing on a given port while still allowing LLDP to be enabled on the switch? Okay, let's log into simulation and see these command options. I have my previous switch, so let me console one of the switch. I just configured earlier this OSPF only. So we'll go to one of the interface which only have interface. We'll go to interface 111. So we'll see no LL. What are the available options? No LLDP transmit is available. Disable the interface to transmit LLDP packets. Okay, let's see. Transmit. Then what is available? Yes, no LLDP transmit is available. Disable the interface to transmit LLDP packet. And other options are not relevant. These are med TLVs. 3 receive. This will disable the receive of this LLDP packets, but our focus is to egressing. So egressing means transmit out of this interface. So we can use no LLDP transmit. Trap is for the SNMP. So these are the available options. So using for the no LLDP command. So it should be the no LLDP transmit. We'll go back to the answers and see. Okay, no LLDP transmit we have seen. This should be the correct answer. But we'll check others. No LLDP interface. No, after LLDP, there was no option like interface. So transmit and other parameters you have seen. There was no parameter like interface. So no LLDP receive is not correct because we are focusing on the egress. So the C is not correct. No LLDP will disable the LLDP function on that port. So actually this is globally disabling LLDP. Under configuration mode, if you put no LLDP, it will disable the LLDP on global mode. So we should not disable the LLDP. We have to still allowing LLDP to be enabled on the switch. So D is wrong. So the correct answer is option A. Okay, let's move on to the next question. This is related to troubleshooting. Refer to this exhibit. Traffic is failing between core 1 and host B. IP addressing has correctly been applied and all interfaces are attached to the VRF green. Which configuration will correct the issue? Okay, let's simulate this setup in our AOSCX simulator. Okay, let's look at this simulation. So you have core 1 and core 2 switches and one PC. And let me show you the show run of these switches. Core 1. This is the running configuration. Here I have created this green VRF as per the question. I have created new VRF called green, and I have assigned this 10.1.1 IP to this interface, and it is attached to VRF green, and it's very simple. That's the only thing I have done. And let me show you the core 2 configuration also. Core 2 also I have created this VRF green. VRF green was created and it is attached to these both interfaces. I have configured 10.1.1.2 into this 1.1.2 interface attached to green VRF, and similarly another subnet is defined 10.120.181 IP/24. This is assigned to 1/1/3. That interface also under VRF green. So we have configured this way, and in this PC, this is the IP assigned for the PC 10.1.20.1, and it is gateway is set as 10.1.20.181 because this is the exit point. If this PC wants to communicate to a different network, so it has to exit from its own network. So this is the exit point. So this is the gateway for that PC 10.1.20.181. That is the interface IP of this core 2. So all these 1/1/1, 2 and 3, they are routed interfaces. That's why we have assigned IPs. Core 1, now if you go to core 1, and core 1 is not able to ping. Let me try pinging this host 10.1, 20.1, which is VRF green. So it says there's no such network. Let's say if you want to see the routes, show IP route VRF green, because all these things are under green VRF, so we have to use the keyword VRF green. So in this routing table, it knows how to go to 10.1.1.0/30. This is the only network it knows. So other than that, it doesn't know any network. So we have to provide routing So we have to provide a static route to go to this network. So it to reach this 10.1.20.0 network, it has to go to this 10.1.1.2. That is the next hop. It has to go to the core 2. So once it goes to core 2 knows how to reach there because it is directly connected. So in core 1 we have to configure static route, that is IP route. Destination network is 10.1.20.0/24. This is the network of this PC. And then the next hop IP, that is 10.1.1.2. Remember, we have to define the VRF also. We have to use the green VRF. Yes, we have to enter. So this is how we created this static route. So now we will see whether we can ping 10.1.20.1 using VRF green. Yes, it is working. So this is the routing issue. So let me show you the routing table. Show IP route VRF green. See, now it is showing a route to this network as the next hop 10.1.1.2 is here. So now it knows how to go to this. Return traffic also knows because it comes here as the default gateway is here. So core 2 knows how it should come to core 1. So this is how we fix the problem. We have to put a static route. We'll go back to the question and check the answers. So the option A, it shows a static route, IP route 10.1.20/24, 10.1.1.2 VRF green. Okay, IP route is correct. Host B, assign the default gateway as 10.1.20. The gateway should be the exit point. So here exit point is 10.1.20.181. It's not 20.1. So 20.1 is the IP of the host B. So A is wrong. Option B, assign the default gateway address 10.1.20.181. Yes, that is correct. But it will not fix everything because we have already assigned 10.1.20.1 as the gateway. But it didn't solve the problem till we created the static route. So option B is wrong. It is not the only issue. And option C, IP route 10.1.20.0, 10.1.1.2 VRF green. Static route is correct. Assign the default gateway address 10.1.20.181. Yes. Option C is correct. Just check the option D. IP route, this is the default route. Default route pointing to 10.1.1.1 in core 2. Core 2, there is no need to put a default route towards 10.1.1 because core 2 is already knows how to reach 10.1.1 because this is directly connected network. So option D is wrong. So the correct answer is option C. Let's move on to the next question. This is under troubleshooting. Second question. Refer to this exhibit. All switches are running Aruba AOSCX while working in the terminal of access 2, that is this switch. You are unable to reach server 1 using SSH. What is the correct command to ping server 1 from access 2 to test reachability? This server 1 is connected to this management interface of the access 2. Okay, let's go back to the previous simulation and we'll connect that PC to the management interface of that switch. Let's connect this interface. This is connected to 1/1/3. Instead of that, we'll connect to the management interface. We'll delete this link. Delete. Then we'll connect this PC to this management interface. Okay. Because we just want to check the connectivity between this switch and the PC. This question is related to only that connectivity. So we don't want to bother about the other things. So let's configure core 2 for this management interface. So let me first check the show run. So interface management is no shutdown, but there's no IP. So DHCP is enabled. Go back to the question. Since we are using the previous simulation, we'll stick to that same server IP. So what we want to simulate is whatever the server or PC is connected to the management interface. Forget about the IPs. Configure and understand the concept. So here we'll use the same IP where we'll remove that 10.1.21.8.1 from the 113. So I will assign to that management interface. So I'll go to the interface 113. I'll put no IP address. No IP address. To put this IP also 10.1.20.181/24. Yes. So let's see whether it is removed. Yes, now no IP under interface 1/1/3. So we'll assign that IP for the interface management. Interface MGMT, IP address, what is the command available? IP should be static. Yes. 10.1.20.181/24. Yes. Enter. Then we'll see, because by default management interface is under management VRF. Since this is a simulation, we have to check this. Now let's try to ping 10.1.20.1, because now this connected interface should be under VRF MGMT in real switches. Since this is a simulation, we'll see whether we need to create it or not. We'll just try. Yes, it is already under MGMT VRF, because by default management interface under MGMT VRF, even though it is not showing here. So now if we use this command ping 10.1.21 VRF MGMT, so we have to use the VRF MGMT when we ping from this switch to this PC or server. So we are pinging this server or PC IP, but include the VRF MGMT keyword, because the management interface under VRF MGMT. So now we have understand what's happening. So let's go back to the question and answers. So what is the correct command to ping server 1 from access 2? The same similar situation. We don't want to bother about these other things. They are not actually relevant for this question. So we have to focus on this connection. So this is the management interface. So we have to use ping 172.168.1.97 and VRF MGMT. So the option A is wrong, VRF default is wrong. Option B is correct, VRF MGMT. Without VRF MGMT, we cannot ping. So option C is wrong, and option D is wrong because it's not ping 6. So correct answer is option B. Okay, let's move on to the next question. This is under manage, monitor and operate Aruba solutions. Okay, the following command is issued under switch prompt. This is privilege mode prompt. Checkpoint rollback start. This is the command you issued. What is the result? Okay, so now we have to understand what is the meaning and function of this command. Let's go back to our simulation. Since we are already in this switch, we'll try to issue this command. Checkpoint rollback. So this is a word. The word there, start or whatever. So it's just a name. It's a checkpoint name. It's not a commanding action. So the checkpoint, rollback, and the name. So the meaning is we are asking the switch to roll back to that checkpoint name. So let's go back to the question and answers. So checkpoint, rollback, start. Start means a name. That is the checkpoint name. So what is the result? Option A. The switch will use the checkpoint rollback as the starting configuration on the next reboot. No, it's wrong. The switch will revert the running configuration to the checkpoint hold start without a reboot. Yes, that is correct, because we are asking to switch to roll back to the checkpoint name hold start. So it looks option B is correct, but we'll check the other options. The command will fail because it is incomplete. No, it is not incomplete. Option C is wrong. The command will fail because rollback commands must be issued from global config mode. No, this is not correct, because we have seen commands are available in privilege mode. So option D also wrong. So the correct answer is option B. Okay, that concludes our training for today. I hope you found this overview of Aruba Certified Switching Associate exam topics helpful. We have discussed sample questions covering the areas such as configuring wired network solutions, network architectures and technologies, functions and features of Aruba products and solutions, optimize Aruba wired solutions, troubleshooting, management, monitoring and operate Aruba solutions. Be sure to check out 591lab.com for more online courses, practice exams, and training materials to continue your certification preparation. You can also visit www.591cert.com to learn more about our full suite of services. If you have any questions or concerns, please don't hesitate to contact us. Thanks for joining today's class, and I wish you the best of luck on your certification journey. Have a great day.